Okay, here we go. So we're going to learn some new vocabulary today. So drawing an angle, the word standard position. So first of all, obviously I can draw an angle floating in thin air as such. And then I could say, I don't know, that's 25 degrees, for example. Yeah, we can all draw, if I said draw an angle of 25 degrees, everybody's going to draw a little differently, right? Yeah. So we've got to make it so that we can all draw it the same, so that you can we can check our answers here. So that's what we do when we draw an angle in standard position. Instead of drawing an angle floating in thin air, we draw on an XY chart. That's all standard position means. Draw an angle on an XY chart. So, couple new vocabulary words here. If I draw an angle in standard position, I've got to have what's called an initial side or starting point. So we're always going to do that at 0. Does everybody see? That's my initial side. Then we're going to draw, let's say I said draw a 25-degree angle. I'm going to go up like this, roughly about from here to here is about, let's say, 25 degrees. So I just drew an angle in standard position. Now this is what they'll call the terminal side. So where you stop is called the terminal side. So the reason we go over that is so that if they say to you, draw an angle in standard position with the terminal side at 25 degrees. Doesn't that literally just mean draw an angle at 25 degrees? Terminal side means stopping point. Everybody good? Okay, just so you don't freak out when you see the word terminal side. That just means stop at that place. Okay, now notice something. When I drew positive 25 degrees, I drew my arrow going up. So I created a positive 25-degree angle. Now I could also draw a negative 25-degree angle if here's my initial side and I go down. Boom, I draw my arrow downwards. That's negative 25 degrees. So we have positive angles, we have negative angles. So you've got to be able to draw your arrow correctly so that we know if you drew a positive angle or negative angle. So positive angles go counterclockwise. Look, counterclockwise, there's a clock. Clocks go around this way. So counterclockwise are positive angles. And then clockwise, or going down, easier to remember, going down is a negative angle. So we have to draw the arrow to determine if it's positive or negative. Any questions on that? Next thing to note. We already know this, just a reminder. This is obviously 0 degrees. Isn't the full circle 360 degrees? So when I hit here again, I'm at 360. So then think about it. Halfway around a circle is 180 degrees, true? And if we cut it into fourths, up here is 90, correct? Add 90, 180, add 90, this is 270 degrees. So those are going to help you draw angles in the correct place. Here we go. So on your homework, number 1 has a typo. Let's start with number 2. We'll come back to number 1. It says, what is this angle that's drawn in standard position? So first of all, a couple things to know with this. This is the hint. You always draw hints with positive amount. How do we know they're asking us for this angle? Because of the arrow. It says, pointing this way, what's this angle? So it's a positive angle since it opens upward. We know it's positive. So how could we figure out that angle? Thank you. Halfway around a circle is 180. Thank you. So 180 minus 60 would be the leftover amount. Good point. How much is that? So question mark equals 120 degrees, everybody. Boom, boom, boom. Easy stuff. Let's go to number 3. It says, what is this angle? This is our hint. The hints are drawn with positives always. Notice the arrow starts here and it's going around this way, making it a positive angle. What would I do to find question mark on this one? Thank you. 360 degrees minus 45 degrees. And how much is that? And this one's a positive angle, right? Opened upwards. So what is it? 315 degrees, everybody. Pretty easy stuff. Okay, let's look up here. Your paper doesn't have this hint right here. So, or like this is the angle we're trying to find. It only gives you the hint. That's the typo. We've got to have an arrow pointing of what angle we're trying to find. So with this one, how could we find this one? Obviously, it's what? 360 minus 60 degrees is, you're saying it's how many degrees? Positive 300 degrees. So none of those were negative, or else we would have had our arrow pointing downward. So so let's go to number 4. It says, sketch this angle in standard position. Now notice when we were going backwards, they always gave us a hint. So we need to do that. So sketching an angle in standard position, guess what I always have people do on the test? They only draw this side. Well, I don't know where you started. You have to draw your initial side at 0. So the first thing you should draw in is this, my initial side starting at 0. Now isn't this 90 degrees right here, everybody? So then going how many more degrees would put us at 100? 10 more. So I'm going to draw my arrow, dot, 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 boom. I'm going this way since it's positive 100 degrees. That's what we drew. Now you do have to put in the hint, because how you draw 100 degrees is going to be a little different than how I draw it. As long as you have a hint, like this distance is 10 degrees, I know we all drew it the same. You see how I drew a hint? 10 degrees. Okay, cool. Let's do another one. Negative 45 degrees. So the first thing you would do is draw in your initial side. Now think about it. Isn't this negative 90 degrees? So halfway between here, I would do my arrow going down, pointing downwards. That's negative 45 degrees. And the hint could be, that's a 45-degree angle right there, or distance, more so, distance. We always draw the hints as positive. That's just the hint. Everybody good? Okay, moving on. Negative 145 degrees. So think about it. Here's 0 degrees. Here's negative 90 degrees. Here's negative 180 degrees. So we would draw in our initial side. Isn't it over here somewhere? Think about it. It's over here somewhere. I don't need to draw it perfectly because I'm going to put in a hint in just a second to show me that we all drew it perfectly. So we knew it was negative, so it's going down, 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 and pointing this way. We just drew negative 145 degrees. Now I'm going to draw in my hint, so let's figure out that distance right there. So how would we do it? It's positive. 180 minus 145. Wouldn't that be the distance between that? 35 degrees. So we would now put in our hint, 35 degrees. Now understand you don't need a hint. If I said draw 90 degrees, there's no hint. That is 90 degrees. Boom, there's no hints we can do here. If it falls right on an axis, there's no hint. Everybody good? So there's not a distance in between anything. Okay, cool. I just said if you drew 90 degrees, there would be no hints needed. Okay, cool. Ready? Do these problems. Drawing hints, drawing initial sides, and so on. So it says find the measure of an angle between 0 and 360 coterminal with each given angle. So why is this good? Because think about it. On the unit circle, isn't it between 0 and 360? The unit circle is drawn between 0 and 360, true? So that's what this is getting us able to see, is that an angle that's negative 100 is also the same angle as what on the unit circle. So wouldn't we just take negative 100 degrees and add 360 to get back to that same spot, but the positive angle, everybody? Okay, 260 degrees literally falls in the exact same spot as negative 100 degrees. We like 260 because it's positive and it's between 0 and 360, which is on our unit circle. Because trig from the unit circle is really easy. So let's go here. We have 482, and we want to find a coterminal angle, meaning fall on the same spot as this, but be on the interval from 0 to 360. So what do we need to do? 482, and then what? Minus 360 to get us back into more of the 0 to 360 unit circle. Because it will fall in the same spot. What is it? What is it? 122 degrees. Isn't that on an interval from 0 to 360, everybody? It falls in the same spot as 482. It's just, that is the positive distance there. Or that's a smaller amount, but it will fall in the same spot. Okay, 660. What's a coterminal angle? Yep, he took 660 minus 360, and he got 300 degrees. So I'm going to ask you a question. If I said to you, draw 660 degrees, if you drew in 300, wouldn't it land in the same spot? Yeah. Yes, it's just, the thing is, if I asked you to draw 660, you probably would go around and kind of make sure that you draw going around more than once. Does that make sense? But at least you know where you're landing. It should land at 300 degrees. Okay, cool. All right, so let's look at 13. It says, are these angles coterminal? So there's many ways we could do this. So I'm going to say, okay, well, I'm going to just go with start at 95 and then see if this is a coterminal angle. So isn't it going negative distance? So I would say, okay, 95 minus 360, what's that? It should be negative, so say negative, what? Okay, so that's not there yet. So let's try subtracting 360 one more time to get closer. So subtract 360 again. We've got to go around the circle again. And what do we get? Negative 625. So are they coterminal? Yes. So this would be kind of my work. I had to subtract 360 twice, but it is coterminal. They do fall in the same spot. So yes. So if we would have ended at negative 626, we would say, no, they're not coterminal. They were close, but not. Right. Okay, it says right here on 17, find a positive and negative coterminal angle of 250. So to find a positive, we would do 250 plus 360. And if it comes out positive, it's a positive coterminal angle. So we get 620 degrees is positive and it's coterminal. So we have a positive coterminal angle. We could do 250 minus 360 and we get negative 110 degrees is our negative coterminal angle because it's negative. Positive doesn't have to be adding 360, everybody. So let's say that we had to subtract 360 and it was a negative answer still, then that's still a negative coterminal angle. It's literally a positive because it's a positive and it's a negative coterminal because it's negative. Okay, so this is 610. Right here? Okay, cool. Good fix. Yes. Okay, so do these problems on coterminal angles. Now, once again, keeping in mind what a coterminal angle is. It will fall in the same spot because we can add 360 as many times as we want, and we could subtract 360 as many times as we want. And that would still land us in that same position. That will help. So a couple of things to note before we start doing the trig of these angles. Make sure you're watching. Once again, there's people already not watching, and you're going to ask questions that I'm going to answer. So if I said to you, what quadrant is angle 120 degrees in, you would say quadrant 2, correct? Because look, quadrant 1, quadrant 2, 3, and quadrant 4. So if I said to you, what angle is negative 60 degrees in, what would you answer? Quadrant 4. Do we get the picture here? Okay, good. Now, other things to note, we are going to learn later, like how to fill out the unit circle, more what it means, how to do it, but I am going to get into some quick basics here. So notice on the unit circle, there's only special angles listed here, if you notice, and they're like equally spaced from quadrant 1, quadrant 2. Do you see what I'm saying? Now think about it. There are more angles than just these in real life, right? I could draw down here 1 degree, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 30, up to 30. Do you get what my point? I could draw unlimited angles here, right? But these angles have special answers. These special angles, and we'll talk about where they come from on another day. So this unit circle only allows us to find trig of special angles on the unit circle. And once again, we'll get into that another time. So everybody look, if I start here and draw up to 30 degrees, right here, that angle is 30 degrees. Does everybody see? Now at 30 degrees, do you see how we have this point, this XY point here, everyone? Now one more thing to note. So if this is 30 degrees, do you see how I have a pi 6 here? What that pi 6 is it's the physical length of the arc that 30 degrees opens up on. So pi 6 is this distance from here to here, like physical distance from here to here, that 30 degrees opens up on. So the pi 6 is equivalent to 30 degrees, where 30 degrees is the angle and pi 6 is the length of the arc. Does everybody understand what I'm saying here? So if I drew in 45 degrees, like I'm going to start here, I'm going to go up 45 degrees. From here to here is 45 degrees. The radian, pi 4, would be the distance from here to here, the physical length of the arc that angle opens up on. So radian and degrees are equal, just one's the angle measurement and one is the length of the arc. Okay, we'll use that later, but I just wanted to get into that a little bit. So remember, the cosine at that xy point is the x value, and the sine at that angle is the y value. So let me say that one more time. The cosine at that angle is the x value, and the sine at that angle is the y value. Cosine is x, sine is y. So note, the reason we just talked about coterminal angles is, do you see how on the unit circle we have all positive angles listed between 0 and 360? So if I ask you to do the trig of negative 60 degrees, a lot of times it's easier to just add 360 and say, well, that is the same thing as 330 degrees. So we're looking at, oh no, it's not the same as I said negative 60. So wouldn't that be the same as 300 degrees, everybody? It's the same spot, it's coterminal, so it'd be easier to just look at this XY point than trying to figure out where that lands, because it lands right there. So that's how you'll use coterminal angles. So let's start using this. So it's really quite easy. This is the exact values. So this unit circle allows us to find exact answers, not decimal answers. Find the exact values of sine and cosine of the angle. So 43 says, find the sine and cosine of 90 degrees. So let's find 90 degrees. Boom. Here's my xy point. Cosine's x, sine is y. So this is how you'd write it correctly. You say the cosine at 90 degrees is equal to 0. The sine at 90 degrees is equal to 1. And if you type it into your calculator, cosine of 90 and hit enter, you'll get 0. If you type in sine of 90 and hit enter, you'll get 1. It's just the unit circle allows us to do it without a calculator. Everybody good? Okay. Pretty easy stuff. Okay, let's do another one. Find the exact value of sine and cosine of negative 240. Now look, I would rather, instead of figuring out, let's say, even though this makes it pretty obvious, like, oh, negative 240, where is that on the unit circle? I would find the coterminal angle, because wouldn't that fall in this exact same spot, but it's the positive amount? So I would take negative 240 and add 360. What angle is equivalent to negative 240? 120. So we're actually, let's do the trig of 120 degrees, since that's a lot easier to look at because it's on our unit circle. So 120 degrees is right here. There's my xy point. So now it's easy. We would say the cosine at, we could say 120, or we could say negative 240, because won't it be the same xy point either way? Cosine at 120 and the cosine at negative 240 is exactly the same thing, because it's that same xy point. So the cosine at 120 degrees is negative 1/2. Then the sine at, I'm going to just write the sine at negative 240, because it's equivalent to saying the sine at 120 is equal to root 3 over 2. Is everybody good with that? No, that is the sine at negative 240, because that is no different than saying what's the sine at 120. Does that make sense? Everybody. Great question. Awesome. Okay. All right, it says find the exact values of sine and cosine of 45 degrees. So locate 45 degrees. Okay. So you could say the cosine at 45 degrees is equivalent to root 2 over 2. Boom, there's our answer. The sine at 45 degrees. Do you see how I'm not finding the coterminal angle? Well, why? Because that one's already on the danged unit circle. You get the point. And the sine at 45 degrees is the y value, root 2 over 2. Okay, 720. Well, that is on my unit circle, but the question is where? So I'm going to find the coterminal angle, so it's easy for me to just see really quickly. So I'm going to subtract 360. What's that? 360. So we can literally say, okay, we're going to do the sine and cosine of 360, because that's in the same spot as 720. So right here is 360, everybody. X, Y. So we could say the cosine at 720 is equal to the cosine's x, 1. We could say the sine at, we could say 720. Couldn't we also say the sine at 360? Same thing. The sine at 360, I'm just changing it up for fun. The sine at 360 is 0. So do you guys see how coterminal angles are useful? Because it gets you back on the unit circle, which would fall in the same spot. So then x and y would be the same value for 720 and 360. They're the same thing. Same sine, same cosine. Same cosine, same sine. All right, here we go. Evaluate sine at 420. What should I really be evaluating? Because 420, I'm going to have to really try to figure out where that's at. So instead, I'm going to subtract 360. So what am I actually finding the sine of? 420 minus 360. So the sine at 120, that's a lot easier than trying to figure out where 420 is, because it falls in the same spot as 120. It's 60? So instead we should be doing the sine of 60 degrees. So then we go to 60 degrees, cosine's x, sine is y, so my answer is root 3 over 2. Boom. Okay, cosine at 270. 270 is already on the unit circle, so I can just go right there. Boom, find 270, which is right here. Cosine's x, so my answer is, the cosine at 270 is 0. Okay, Okay, let's go to tangent. Now, can anyone remember from last time what tangent is on the unit circle? No, it's not. It's just dividing a fraction, so that's not that bad. Y divided by x. So remember that tangent at an angle is the y value divided by the x value, the sine over the cosine. All right, we can do that. So sine at 240. 240 is on the unit circle. Boom, I can find it easily. Boom, right there. Here's my xy point. You say tangent is the y value, which is negative root 3 over 2, divided by the x value, which is negative 1/2, everybody. So dividing fractions, we have to do it by hand. Yep, easiest by flip the second and multiply. So on top I'd have negative 2, on bottom I'd have 1. Wouldn't these divide out? So my final answer on tangent at 240 is negative 1 times negative root 3, which is root 3. The tangent at 240 is root 3. Let's do a tangent at 135 degrees. So now once again, 135 is on the unit circle. Boom, right there, my xy point. You do your y value, which is root 2 over 2, divided by the x value, negative root 2 over 2. So it's negative 1. Anything divided by itself is 1. Do you see how Colton's seeing that so quickly? Something divided by itself is 1. Something divided by its negative self would be negative 1. Okay. Now for all you advanced thinkers out there, cosecant and secant of these angles. So, can anyone remember what cosecant is the reciprocal of? So, it's sine. Remember how we talked about it's the opposite? C and S go together? Because we see C and we want to go with C, but it's actually the opposite. So it's the reciprocal of sine. So what you can do is say, okay, I'll come back to cosecant. Let's find the sine at 60. So go to 60. Sine is y. So my answer of sine of 60 is root 3 over 2. So cosecant literally means the reciprocal of sine. Yep, so 2 over root 3. Do you see how I just reciprocated that? So that'd be my answer. You'd say, that is my answer, except I just have to simplify my final answer by rationalizing my denominator. So my final answer would be 2 root 3 over 3. So cosecant of 60 is 2 root 3 over 3. All right, secant. C and S go together. That's the reciprocal of cosine. So let's first find the cosine at negative 45 degrees, and then we'll just reciprocate it. So cosine at negative 45 degrees, isn't this negative 45? Cosine's x. So my answer here is root 2 over 2. Reciprocate it, and we get 2 over root 2. That's your answer. You would then rationalize your denominator. So you'd multiply by root 2, root 2. So now on top, we would have a 2 root 2. What would we have on bottom? 2. So final answer, the secant of negative 45 degrees is equal to root 2. Okay, awesome. That is the end of the lesson. So what I need you to do is finish the worksheet, and then when you're done and hand that in, do these on a whiteboard, because there's not any practice like this, but there is on the test. When you finish, hand it in. Do these problems on a whiteboard, check them off with me.